Hello friends, I am Amit Bhatia and along with me Kanav Bhatia is here. So we together have made this presentation on hydraulic valves and power packs. So we'll let you go through this presentation so that you can have fair good idea about what hydraulic valves and power packs are all about, how they're built, how various calculations are done. Now this video presentation has solely been made by me on my practical experience while working with various companies dealing in hydraulic circuits and power packs such as Herian, GmbH, Indian JV with Escorts in 90s, JCB India and Terex Construction Indian Venture. The contents and various conclusions and calculations may differ due to various practical losses and assumptions made by any other expert. Overall, I can say this video will give you a fair good knowledge for understanding the basics of hydraulic circuits and power packs. So hope you enjoy this. This is the index of hydraulic valves and power packs. First, we'll let you go through the functioning of various kinds of valves. So we'll start with pressure control valves, flow control valves, throttle check valves, throttle valves, direct acting types or non-stackable types, and 6 direction control valves, which are the most vital valves in any hydraulic power pack or hydraulic circuit. And 7th will let you go through the hydraulic power pack basic construction details. Now we'll understand here what is the difference between stackable and a non-stackable hydraulic valve. As the name suggests, stackable valves are those valves which are assembled in a cluster or a stack formation in a power pack. These valves have oil galleries openings on its opposite faces. It's only on one face in case of a direction control valves. That's why in a stack in a hydraulic power pack, direction control valves are placed at the topmost level. In between there are other valves like pressure control valve, pressure relief valve, flow control valves. Now these valves are used along with manifold blocks that has oil gallery openings to suit these valves openings, along with pipe connection for feed pipes coming to and fro from the hydraulic oil tank of a power pack. You can see in the figure we have shown one direction control valves. On one face it has got oil galleries which open in the central bore of the valve, which has got different grooves. So you'll understand and you'll see the basic functioning later on in the later on slides. Similarly, non-stackable valves are those valves which are assembled directly on a feed pipe. So now these valves, such as flow control valves, these valves have pipe threads on their valve body itself. So they do not require any separate manifold block for assembly onto a power pack stack. Now I'll go through the pressure control valves. Now they can be categorized into 4 categories: pressure relief valves, pressure reducing valves, sequence valves, and counterbalance valves. So you'll understand the basic functioning of all valves later on. Here we'll go through the pressure relief valve first. These are those valves that release the excessive pressure of oil to the tank line or tank, or these are the valves that allow the system to operate at a constant hydraulic pressure. That is the pressure at which the spring inside the valve has been set, and thus the excessive flow of the hydraulic oil, which could cause more pressure in the system, is released into the tank line or tank. You'll see the sketch in the next slide, you'll understand it better. This is it. So you can see on top there's a hydraulic cylinder. Each side of the cylinder have been named A and B side. Now you can see the direction control valve symbol, in which first solenoid operation the P or pump line is connected to the A line. Now here in the A line only we have fixed the pressure control valve or pressure relief valve. So you can see pressure relief valve is a offline functioning valve. That means the line directly goes, the galleries are directly open from P to A, and in this position of the valve solenoid, and when the oil goes into the A side of the cylinder, as you can see in the sketch, the excessive pressure, which is sufficient to move the spring inside the valve, makes the excessive pressure hydraulic oil go back to the hydraulic tank. We'll see the functioning. Similarly, when we change the position of solenoid, then you'll see it again. This is it. Now pump line is connected to B line. Next is the pressure reducing valves. As the name of these valves suggests, these are the kind of valves that let the part of whole hydraulic system to operate at a pressure that is less than that of the main line or pump line. And you'll see the next slide. Here you can see, this is it. Here, this is a online valve. That means the P to A oil galleries are connected through the valve's spool that is inside the valve main bore. So as you can see, when the pressure is high and you want to reduce the pressure, so the spool inside the valve moves and it reduces the opening like in any common tap. So that will help less oil with less pressure to go to the cylinder. You can see. Now next is the pressure sequence valves. Now these are the mainline valves that open the oil flow galleries at a specific minimum pressure. Now suppose we need two or more processes to be performed in a hydraulic circuit in a particular sequence, that is one after the other. Then we can use lesser pressure setting valve for earlier process and higher pressure setting valves for the later process. For example, see the sketch. Here in this sketch, we have shown you it could be like in a lathe machine, you need that the clamp of the jaws should function first before the turret moves. Both operate through the hydraulic system supposedly. So you can set the lesser pressure reducing valve onto the sequence valve onto the jaw line, and next one to the turret line, the higher one. Now next is the counterbalance valves. So these are those valves that are used to counter the dead weight of some vertically sliding objects such as elevator, lifts or punches. In case of punch presses, its operating pressure is set much more than the hydraulic pressure value that is caused by the dead weight, so that when the system fails due to any breakdown, the weight doesn't come down suddenly by itself. Theoretically, it works similar to pressure sequence valve when installed in a reverse position. See the sketch. So this is the schematic diagram of a cylinder, supposedly of a punch press or of an elevator. So when the counterweight exerts the pressure on the line, still the valve spool will not move. It will move only when through the hydraulic power pack we apply some excessive pressure. Then that is sufficient to move the spool inside the valve, and then only the dead weight can come down. So it is fail to safe power pack valve. Next is the flow control valves. As you know that an orifice is a narrow streamlined passage, the flow rate of a fluid passing through an orifice can be formulated as QAO is equal to KA0 under root delta P, wherein delta P is nothing but the difference of pressure at both ends, where the orifice is there and where the where the normal feed pipe is there. And A0 is the cross-sectional area, K is a constant here. So you can understand from this, where P1 is the pressure at the beginning of the cross-section and P2 is the pressure at the end of the cross-section and K is a constant. So from this equation we can see the flow rate of a fluid through a passage can be varied by increasing decreasing the cross-sectional area of the passage, which can be done by a notch cut spool or a pin with threads on it, and thus moving the pin in or out the passage opening, in the passage opening. Now let's consider a machining operation where pressure also fluctuates with the operation, such as drilling operation, because it has got packing and you never know, how much thrust is required each time to move at a constant flow rate inside the metal body. So delta P varies here, and which in turn will vary the flow rate of feed. So to compensate this, in these valves a spring-loaded spool is used and the inlet and outlet pressure linked to both sides of the spool respectively. This way that any fluctuation of pressure at outlet, delta P will remain constant. And again, only by varying the area of cross-section we can control the flow rate, that is feed of the cutting tool or drill also. So these flow control valves are also called pressure compensated flow control valve. So irrespective of the back pressure drill is generating, it will move at a constant feed, for example. Next is throttle check valves, stackable again. These are the non-pressure compensated flow control valves and have check valves in the main line. I've given the here in old nomenclature. See the symbol. So this is nothing but a normal flow control valve, wherein you can turn the throttle to have a varied flow, but it will not be a pressure compensated one. Similarly, you have got check valves. This is a symbol of a check valve. These are just check valves that allow the flow in one direction only. They have different nomenclature depending upon which line A, B, P or T the check is applicable. So it will only one direction valve. The oil will not come back. Now throttle valves, non-stackable. These can be defined similar to throttle valves that we have done earlier, the stackable ones. Only difference is that these are standalone valves and can directly be used in a main line, and these are not stackable. So as you can see, this is in first slide also we had shown. Now the most important valves are the direction control valves. Here we have explained you the solenoid operated ones. These are stackable valves. Like all stackable valves, these are 4 ports on one face that are A, B, P and T. Common 4-port 3-position DC valve symbol representation is shown below. It is evident from this that when the spool inside the valve is in center position, all lines are closed. However, when we move the spool through solenoid on left side, P pump line is connected to A port at output and so on. Similarly, we can have a central position, we can have a right position also. Functioning of a direction control valve. In hydraulic valves, direction control or may it be any other valve, there are oil galleries on one side of the valve for pump, tank, hydraulic cylinder, incoming and outgoing oil that open inside the grooves cut in the common bore of the valve. Now in direction control valve, there is only oil galleries opening only on one side, wherein in all other valves, pressure relief, pressure sequence, stackable flow control, there are oil galleries on both sides, because these valves have to come as a sandwich in a stack cluster on a power pack. So you'll see later on in the power pack sketch. Now in this common bore, a spool is assembled with a very narrow clearance fit, say 2 to 8 micron. This spool too have grooves on it, and when the spool is moved inside the valve bore, either through solenoid or manual push or through any other mean, the oil gets passage to move in between the oil openings as per the desired use. See the sketch, you'll understand it better. This is it. This is the neutral position in a direction control 4x3 direction control valve. 4x3 means 4 ports, 3 positions. So here we have shown the middle one, neutral position, wherein oil, no path is open for this position in case of a direction control valve. This direction control valve, you can see now it's moved to the left side. So oil galleries are open, P line to A line and B line to T line in case of this direction control valve. Again we shift it to the, here you can see the oil gallery is opening. So oil could pass from P to A and B to T. This is when we move the spool and through solenoid to right direction. Oil galleries paths are open, P line to B line and A line to T line. In case of this direction, you can see here like this. So similarly, we can have different functions in direction control valves, and we can have different symbols also. This is the most common one we have shown here. Now comes a hydraulic power pack. I'll show you the basic construction detail. Simple hydraulic power pack consists of hydraulic tank with air breather, return line filter, oil level gauge and openable lid. Motor fitted with a gear pump or an oil pump, feed piping, wall stack including manifold block, and we had explained earlier, you need a block wherein the oil gallery openings are routed to the feed pipe openings. That's how, so that because the oil comes from a power pack and goes back to the tank through the feed pipe, so you need a block wherein these feed pipes are connected through pipe threads openings to manifold, and which have angular holes in it and as per the pattern on the valves. Then pressure control, pressure relief valve, flow control valve, direction control valves, as per your use you can have the stack. On the topmost there will be direction control valve because it has got oil galleries opening only on one side. Now we'll see the basic construction detail on hydraulic power pack calculations. Here separately hydraulic valve stack have been shown. This is a sketch of a press, hydraulic press. Now let's understand how to calculate the flow rate. Suppose in this press the diameter of the cylinder is mm and the speed of the stroke we require is, or the feed is f mm per minute. We can easily find out the flow rate of the hydraulic oil inside the cylinder with the following expression. That is, we calculate the volume of the cylinder with respect to the speed per minute, feed per minute. So we'll have pi d square by 4 into f divided by 10 to the 6 liter per minute, LPM. So you got 10 LPM the flow rate. Very easy calculation, anybody can do it. Next is the pressure in bars, how to calculate in a hydraulic cylinder. Suppose it is required for press operation to exert a load of n newtons on a workpiece, then we can find out the pressure in bars for the hydraulic cylinder with the following expression. That is, say the diameter of the cylinder again is d mm. The pressure we require the hydraulic cylinder to operate at, load in newtons divided by cylinder area, cross sectional area, that will be in bars if you divide by the bar factor. So you'll have the pressure in the cylinder, required pressure in bars like this. So now we have got the LPM and the pressure. So now we'll calculate the motor capacity in HP. Now we got flow rate of the hydraulic oil required in LPM, pressure required in bars. Using above two numbers, we can find out the power capacity of hydraulic motor in terms of HP. You can see motor power, we'll do it through PV expression, flow rate into pressure in terms of what we'll get. So you'll get, in simple terms, the motor power would be equal to LPM into bars divided by 450. That will be in terms of HP you'll get, horsepower. Now since we know LPM pressure and rating the motor gear pump, we can start building the power pack. Primarily we need to have the following parts in a power pack. Number one is a hydraulic oil tank fitted with an opening plate, level gauge, air breather, return line filter, motor gear pump with fittings and feed pipes. Manifold block, it is required again, as I told, to convert the pipe fitting and the adapters from feed pipes fittings to stackable valves oil galleries. The next is a combination of direction control and other hydraulic valves. So here we have shown the basics, what all are there in a power pack. Direction control valve, as you can see, is on the top, other valves, pressure control valves, etc. Then a manifold block is there to convert the feed pipes connections to valves oil galleries, to suit the oil galleries in a direction control or other valves. You can, we have shown the oil galleries. You'll see now examples and usage of hydraulic power packs. Here you can see it's a 4x3 again direction control valve being used in this. This is position 1. So you'll see next how it moves. This is how it's moving down, then again back when you move the valve solenoid into position 2. Next would be, next example will show you of a scissor lift, hydraulic scissor lift. Again you can see here we used 3x3, that means 3 positions and 3 oil galleries direction control valve. So you can see when it's in position 2 it's lying down, then we move it to position 1, it's up, again up, then position 3 down, again down. So this is a summary we have given for designing and troubleshooting for a hydraulic power pack. We can design any power pack with conventional valves using basic calculation in previous section. Attention to be given during stacking of valves in a power pack, such as the manifold block has to come at the bottommost level, and above that other valves such as pressure control, check valves, etc. would be assembled, followed by direction control valve. At the topmost must be installed, since direction control valves have ABPT ports only on one side of the valve commonly, and then pressure can be measured by in the pump line. In the tank line the pressure shall always be nil. Due to obvious reason, oil is free falling into the tank. Next is, now here we have given the basic troubleshootings. Always use clean hydraulic oil, since contamination can damage the spools or oil galleries inside the valves. In case of a 3-phase motor pump, reverse connection can affect the performance of the power pack, since the gear pump flows little oil even if run in the reverse direction. So take care during installation. This is a normal breakdown we get in industry when we move the power pack from one station to another and we could reverse its electrical connection. That makes it go slow, and we do not understand the reason why it has gone broken down. But once we reverse the connections again, it will again start functioning normally. Have a periodic routine preventive maintenance schedule for better upkeep of the power packs. It must consist of check the oil level in a power pack, prevent any visual oil leakages, clean the return line filter as well as complete power pack periodically. In case, check and replace any damaged O-rings around PT, A and B ports of the manifold or any other valves, or check for spools inside the valves. This is all. Thank you. For any suggestions, in case of any suggestions, doubt, please mail us at kanabhatia1997@gmail.com. Please subscribe if you want similar good new training videos as well.